Okay, question 16, we have this scenario here. So we know that these two angles are going to be equal to one another because they're vertically opposite one another. Vertically opposite, if we turn it like that. So we can rewrite these to solve them. So we know that 5x minus 20 equals 3x plus 10. So we want to take our 3x, we want to eliminate our 3x here. So take away 3x, and we do the same on this side. Take away 3x. So we end up with 5x, take away 3x leaves us with 2x minus 20 equals 10. Okay, now remember these are degrees. Okay, and then finally we want to go plus 20 degrees to get rid of this negative 20 degrees. So we end up with, and the same on this side, plus 20 degrees. So we end up with 2x equals 30 degrees. And then finally, to get rid of the 2, we would divide by 2 and divide by 2. So x equals 15 degrees. Let's firstly look at what we've got here. We've got parallel lines here and here, and parallel lines here and here, okay? And we have 4y and 2x and 80 degrees. So if we have 80 degrees here, we know from our work with transversals that this then becomes a corresponding angle to here, and that gives us there 80 degrees there, okay? That then tells us that this across here, this 180 degrees, okay? If that's 80 here, then that must be 100 on the other side, okay? So this must be 100 over here, okay? And from our corresponding angles here, that makes that one there also equal to 100. So then it's just a simple case of saying, well, 4y equals 100 degrees. So therefore, y must equal 25, okay? And here you've got 2x must also equal 100 degrees. So therefore, x must equal 50 degrees to halve that. Again, we're dealing with parallel lines and a transversal. So we've got the parallel lines here, okay? And we're looking for these little arrowheads to tell them they're parallel lines. Now, this diagram is quite interesting because I don't really like it, because if you look closely at the diagram, this line here has a marker to this line here that indicate that they're the same length. But on the diagram, they are clearly not the same length. So anyway, we'll work with what the diagram tells us and work forward from there. So again, with parallel lines, we can tell this 50 degrees here then gives us a corresponding angle to up here at 50 degrees. And once we know that that one's equal to 50 degrees, we then know that this 180 degree angle here of the straight line, we can then do some calculation there, and we now know that this angle here will be, so it's 180 take away 50 equals 130, and then we know that y plus 30 equals 130, okay? And therefore y must equal 100 degrees in here, okay? So that's relatively straightforward, okay? We then have this scenario here where we've got these two lines are the same length, okay? Now this makes it a scalene triangle, which tells us that this angle here must be the same as this angle here, okay? So in other words, that one's also 50 in here. So I'll put a little arrow here. That's also 50 degrees, okay? Once we know that, we then know that a total of a triangle is 180. So 180, take away the 50 and the 50, take away the 100. It's going to leave us then with 80 degrees. And so 5x, so that equals 5x, okay? And then to find out x, we just divide that by 5, okay? And get our answer from there. So 5 goes into that 16 times, so therefore x must equal 16 degrees, okay? But again, the diagram itself in the question, I don't think was accurate to what was being represented.